Imagine a world where cars build themselves, where factories run 24/7 with zero human workers, and where your next vehicle is custom printed in just hours. Sounds like science fiction? Think again. The automotive industry is undergoing a revolution unlike anything we've seen before, and the future is arriving faster than you think. From AI-powered robots to 3D printed cars, the way we manufacture vehicles is changing at lightning speed. And if you're curious about how this will affect the cars you drive, the jobs of the future, and even the price tags on new models, stick around because today we're diving deep into the future of automotive manufacturing. The rise of the robotic workforce is transforming industries far beyond the automotive sector, ushering in a new era of automation that is reshaping the global economy. From warehouses and hospitals to agriculture and hospitality, intelligent machines are taking on roles once thought to be exclusively human. In logistics, companies like Amazon and FedEx now rely heavily on autonomous robots and drones to streamline operations and reduce delivery times. In healthcare, surgical robots and automated diagnostic systems are enhancing precision and improving patient outcomes. Meanwhile, farms across the globe are adopting robotic harvesters, drone crop monitors, and automated irrigation systems, enabling farmers to produce more with fewer resources. Even fast food chains and hotels are deploying robots for tasks such as cooking, serving, and cleaning, all in the name of efficiency and consistency. This surge in robotic integration is driven by advancements in artificial intelligence, machine learning, and sensor technology, making robots smarter, more adaptable, and cost-effective. While some fear job displacement, the robotic workforce also creates new opportunities in tech development, maintenance, and oversight, signaling a shift in the nature of work itself. As we move deeper into the 21st century, the robotic revolution is not just about replacing human labor, but augmenting it, unlocking unprecedented productivity and pushing the boundaries of what machines and humans can achieve together. The rise of the robotic workforce is transforming industries far beyond the automotive sector, ushering in a new era of automation that is reshaping the global economy. From warehouses and hospitals to agriculture and hospitality, intelligent machines are taking on roles once thought to be exclusively human. In logistics, companies like Amazon and FedEx now rely heavily on autonomous robots and drones to streamline operations and reduce delivery times. In healthcare, surgical robots and automated diagnostic systems are enhancing precision and improving patient outcomes. Meanwhile, farms across the globe are adopting robotic harvesters, drone crop monitors, and automated irrigation systems, enabling farmers to produce more with fewer resources. Even fast food chains and hotels are deploying robots for tasks such as cooking, serving, and cleaning, all in the name of efficiency and consistency. This surge in robotic integration is driven by advancements in artificial intelligence, machine learning, and sensor technology, making robots smarter, more adaptable, and cost-effective. While some fear job displacement, the robotic workforce also creates new opportunities in tech development, maintenance, and oversight, signaling a shift in the nature of work itself. As we move deeper into the 21st century, the robotic revolution is not just about replacing human labor, but augmenting it, unlocking unprecedented productivity and pushing the boundaries of what machines and humans can achieve together. 3D printing is revolutionizing the manufacturing landscape, and the automotive industry is rapidly embracing this groundbreaking technology to produce cars on demand. No longer confined to prototyping in small parts, 3D printing, also known as additive manufacturing, is now capable of producing full-scale vehicle components and even entire car frames with remarkable speed and precision. Companies like Local Motors, with its 3D printed straight tie, have already showcased the potential of printing cars in a matter of days, drastically reducing the need for large-scale factories and traditional assembly lines. This shift enables hyper-customization, allowing customers to design vehicles tailored to their exact specifications, from body shape and color to interior layout and performance features. Additionally, 3D printing reduces material waste and can incorporate lightweight yet strong composites, improving fuel efficiency and sustainability. Startups and legacy automakers alike are exploring the potential of digital blueprints and localized production hubs, where cars can be printed closer to the point of sale, cutting down on shipping costs and emissions. As this technology matures, We could see a future where ordering a personalized car becomes as simple as downloading a file and having it printed in a nearby facility. The implications are profound, not just for how we make cars, but for how we think about ownership, mobility, and the entire supply chain. The green factory revolution represents a seismic shift in manufacturing practices as industries worldwide embrace sustainability to minimize their environmental footprint. With increasing awareness of climate change and resource depletion, businesses are investing in eco-friendly technologies and processes to reduce emissions, conserve water, and lower energy consumption. This revolution is characterized by the integration of renewable energy sources like solar and wind power into factory operations, drastically reducing reliance on fossil fuels. Factories are also incorporating energy-efficient machinery and advanced automation systems that optimize production while minimizing waste. In addition, innovative practices such as circular manufacturing are becoming more widespread, where products and materials are designed with their entire life cycle in mind, from sourcing raw materials to end-of-life recycling. The use of green building standards, such as LEED-certified factories, ensures that structures themselves are energy efficient, using sustainable materials, improved insulation, and smart lighting systems to cut down on energy usage. Companies are also shifting toward biodegradable or recyclable packaging, reducing plastic waste, and embracing plant-based materials. The green factory revolution is also driving the adoption of electric and hydrogen-powered industrial vehicles and the use of 3D printing, which reduces material waste and the need for traditional manufacturing processes. This movement is not just about environmental responsibility, it's a competitive edge. Consumers are increasingly demanding sustainable products, and governments are introducing regulations that encourage green manufacturing practices. As industries embrace these new methods, the future of production looks brighter, with cleaner, more efficient factories leading the charge toward a sustainable and circular economy. The green factory revolution holds profound implications for individuals, reshaping the way we interact with the products we use and the world around us. As companies transition towards sustainable manufacturing, consumers can expect to see more eco-friendly products that are not only better for the environment, but also healthier and more innovative. For example, the growing demand for sustainably produced goods means you may have access to products made from recycled materials or those designed to be fully recyclable at the end of their life, reducing waste in landfills. This could extend to everyday items, from electronics to clothing, offering you a broader range of eco-conscious choices. Moreover, the widespread adoption of renewable energy in factories may lead to a reduction in energy costs over time as the global shift toward clean energy accelerates. As green technologies mature, individuals may also experience new opportunities for employment in emerging green industries, from renewable energy tech to sustainability, consulting, and eco-friendly product development. Additionally, the shift to sustainable manufacturing practices may impact your lifestyle by encouraging you to adopt more sustainable habits, such as buying locally produced, energy-efficient, or upcycled goods. In the long run, the green factory revolution isn't just about cleaner factories. It's about transforming global supply chains to create a more sustainable, healthier world for future generations, and ultimately, it's you as a consumer, employee, or citizen who will benefit from these positive changes. The revolution is reshaping not just industries, but also the very way you engage with products, services, and environmental stewardship on a daily basis. The rise of AI-powered dark factories marks a revolutionary leap in the manufacturing industry, where automation and artificial intelligence replace traditional human-driven processes to create fully autonomous production facilities. Unlike conventional factories, dark factories operate without the need for human workers on the floor, relying entirely on robots, sensors, and AI systems to manage production tasks such as assembly, quality control, and inventory management. These facilities are designed to be highly efficient, operating 24/7 with minimal human intervention, which significantly reduces operational costs and increases throughput. The term dark refers to the fact that these factories often don't require lighting, as they are operated remotely, and they may be located in less accessible areas since human oversight is limited. The integration of AI allows for real-time decision-making, optimizing production processes, predicting maintenance needs, and responding to fluctuations in demand without the delays caused by human decision-making or errors. For example, AI algorithms can adjust production lines based on supply chain data, automatically switching between product types or adjusting quantities to meet customer orders in real time. While this level of automation promises unparalleled efficiency and cost-effectiveness, it also raises concerns about job displacement, as many roles traditionally occupied by humans are now replaced by machines. Additionally, dark factories bring challenges related to cybersecurity, as the reliance on interconnected systems increases the vulnerability to cyber attacks. Nevertheless, as AI and robotics continue to evolve, dark factories are poised to redefine the future of manufacturing, allowing companies to produce goods at unprecedented speeds and precision, while potentially reshaping the global workforce in the process. These AI-driven facilities could be the backbone of industries such as automotive, electronics, and consumer goods, creating a new wave of production that is fast, efficient, and, in many ways, invisible to the human eye. 3D printing, or additive manufacturing, is challenging the very foundation of traditional assembly lines, offering a radically different approach to production that could spell the end of conventional mass production methods. Unlike traditional manufacturing, which relies on complex and costly tooling, molds, and assembly lines to produce large volumes of identical products, 3D printing allows for the direct creation of components or entire products from digital designs. This means that instead of relying on an extensive assembly line where parts are assembled in a linear fashion by human workers or machines, products can be printed layer by layer in a single process. This shift can significantly reduce the need for large-scale infrastructure, minimize material waste, and offer the ability to rapidly prototype and customize products without incurring high setup costs. With 3D printing, companies can create bespoke products or small batches on demand, making traditional mass production methods seem less efficient for certain industries. For example, automotive manufacturers are already exploring 3D printing for spare parts, tools, and even vehicle components, enabling quicker turnaround times and a more localized production model. Instead of having to build large inventories, companies can simply print what is needed when it's needed. This on-demand capability also means that global supply chains can be reimagined, as 3D printers can be deployed locally to produce parts close to where they're needed, reducing shipping costs and environmental impacts. Beyond the efficiency gains, 3D printing allows for an unprecedented level of customization, where consumers or businesses can request unique or specialized features in their products without the high costs typically associated with traditional manufacturing. However, while 3D printing holds the potential to disrupt traditional assembly lines, it is unlikely to fully replace them in the near future, especially for industries where speed and scale remain critical. Instead, we're likely to see a hybrid model emerge, where 3D printing supplements and enhances traditional manufacturing rather than completely replacing it. The real potential of 3D printing lies in its ability to offer new, more flexible, and sustainable ways of making things, fundamentally changing how we think about production, supply chains, and product customization. As the technology matures, we may find that traditional assembly lines, while still useful for large-scale production, will increasingly coexist with, and in some cases, be supplanted by, this cutting-edge digital fabrication method. Self-healing materials represent a groundbreaking innovation that could fundamentally transform the automotive industry, particularly in the way vehicles handle wear and tear. Imagine a car that can automatically repair scratches, dents, or even cracks in its bodywork without needing to visit a repair shop. This is the promise of self-healing materials. These advanced materials are designed to mimic biological processes, enabling them to heal themselves after being damaged. In the automotive context, self-healing materials are typically embedded with microcapsules or microfibers containing a healing agent. When a material is damaged, such as when a scratch punctures the surface, these capsules rupture and release the healing agent, which then bonds the damaged area back together, restoring its integrity. This could significantly reduce the need for frequent touch-ups, paint jobs, and minor repairs, resulting in lower maintenance costs and a longer lifespan for vehicles. The potential applications of self-healing materials in cars extend beyond just the exterior. They can be integrated into various parts of the vehicle, including tires, seats, and even the interior dashboard, where wear and tear often takes a toll over time. For example, self-healing polymers could be used to create tires that automatically repair minor punctures, reducing the risk of flat tires and enhancing safety. Moreover, self-healing coatings could protect the car's paintwork from chips or scratches caused by road debris, keeping vehicles looking new for longer and reducing the environmental impact of repainting. This innovation also holds promise in enhancing vehicle safety, as self-healing materials could potentially restore the integrity of structural components in the event of a minor collision, minimizing damage and improving crash resilience. While the widespread adoption of self-healing materials in cars is still in its early stages, the technology is rapidly advancing. Researchers are working to make these materials more cost-effective, durable, and versatile so that they can be scaled up for mass production. As we move toward a future of smarter, more sustainable vehicles, self-healing materials could play a key role in redefining vehicle maintenance and performance, making cars not only more resilient, but also more efficient in the long run. The green factory revolution is reshaping the manufacturing landscape, driven by the urgent need to combat climate change and reduce environmental impact. At its core, this revolution focuses on adopting sustainable practices and cutting-edge technologies that enable factories to reduce their carbon footprint, minimize waste, and optimize resource usage. A key element of the green factory model is the shift toward renewable energy sources, solar, wind, and geothermal, replacing fossil fuels to power production processes. Factories are increasingly investing in energy-efficient equipment, such as advanced lighting systems, smart heating and cooling, and machinery that uses less energy, reducing overall consumption and lowering operational costs. Another pivotal aspect of this revolution is the adoption of circular economy principles, where materials are reused, recycled, or repurposed rather than discarded. In green factories, waste materials are often transformed into new products or components, minimizing landfill usage and conserving valuable resources. For example, some manufacturers are using recycled plastics to create new products or designing modular systems that allow for easy disassembly and recycling at the end of a product's life cycle. Water conservation is also a priority, with closed-loop systems being implemented to recycle and reuse water in production processes, further reducing environmental strain. Moreover, green factories are leveraging smart technologies like the Internet of Things, IoT, artificial intelligence, AI, and automation to optimize efficiency, reduce waste, and track sustainability metrics in real time. AI-powered systems can predict when equipment will need maintenance, helping prevent inefficiencies, while IoT sensors monitor energy and water usage, ensuring that factories operate as efficiently as possible. The integration of sustainable supply chains further supports this transformation, encouraging manufacturers to source raw materials responsibly and work with suppliers who prioritize environmental stewardship. The green factory revolution is not just about reducing emissions and waste. It's about rethinking the entire manufacturing process. By adopting more sustainable methods, manufacturers are not only contributing to environmental preservation, but also creating economic opportunities through innovation. As consumer demand for green products grows, companies that embrace these practices are better positioned to meet regulatory requirements, improve their brand reputation, and appeal to environmentally conscious customers. Ultimately, this revolution is a crucial step toward creating a more sustainable, resilient industrial future, one that balances economic growth with environmental responsibility and sets the foundation for a cleaner, greener world. Digital twins are revolutionizing the way cars are designed, tested, and refined, offering automakers the ability to simulate and analyze every aspect of a vehicle in a virtual world before it even exists in the physical one. A digital twin is essentially a highly detailed, real-time digital replica of a physical object, process, or system, in this case, a car. By using data from sensors, simulations, and real-world performance metrics, automakers can create an accurate, virtual representation of a car that behaves exactly like its physical counterpart. This allows engineers to run simulations, assess performance, and make design adjustments without the need for physical prototypes, significantly reducing both time and costs in the development process. One of the key advantages of using digital twins in the automotive industry is the ability to test a car under virtually any condition, from extreme weather to high-speed maneuvers, before the car is even built. For example, manufacturers can simulate how a car's components, like the suspension, engine, and braking system, will perform in various scenarios, such as driving on icy roads or navigating rough terrains. This ability to test and optimize a car's design virtually ensures that it meets safety, efficiency, and durability standards without the need for costly physical testing of multiple prototypes. Digital twins also play a crucial role in improving vehicle safety and performance. By simulating how a car responds to crashes or other high-stress situations, automakers can make design improvements to protect passengers more effectively. Additionally, the data gathered through virtual tests can help in fine-tuning fuel efficiency, aerodynamics, and even the driving experience to meet consumer demands for better performance and sustainability. Beyond the design and testing phase, digital twins can also be used to monitor a car's performance in real time once it's on the road. For example, the virtual twin of a vehicle can track data such as engine temperature, tire pressure, and fuel efficiency, alerting drivers to potential issues before they become serious problems, and helping manufacturers provide better maintenance and upgrade services. In the future, digital twins could be integrated with artificial intelligence and machine learning to predict vehicle performance over time, offering insights into how cars will behave under various conditions throughout their life cycle. This could lead to the development of more reliable, efficient, and safer vehicles. The use of digital twins is not just a technological leap for the automotive industry. It's a glimpse into a future where cars are tested, improved, and maintained in a digital space long before and after they hit the road.